All right, so next up is Jared. Jared has probably the most difficult slot during the Troopers because it's in parallel to the surprise talk, which is a very surprising talk, but I'm glad you all made it here. Jared is going to talk about a C2 framework, and stage is yours. There you go.
Thank you very much. Hey. All right, so yeah, this is introducing Faction. It's a C2 framework that a friend and I have been working on for a long time now that we're really excited to release. My name is Jared Haight. I'm a red team operator for X-Force Red. We're IBM's offensive security team that goes in and hacks customer stuff and helps them fix their stuff and become better and more secure. Not up here today is Dr. Harris Bonkers. He's a really good friend of mine that from pretty much day one has been helping me out with Faction and has contributed just a ton of stuff to it. So really grateful for his help. So let's talk about what Faction actually is and why I'm so excited about it. Faction started out as we wanted to build a .NET C2 platform. It was obvious that PowerShell, the legs on PowerShell were running out. It's in another year, it just won't be a viable offensive platform in most situations. And even now, there's a lot of organizations that if you're trying to leverage PowerShell, you're more likely to get caught because the PowerShell team has done such a good job of hardening it and adding logging and stuff like that. They've really taken PowerShell from being a attacker's plaything to being really a defender's toolkit, and that's awesome. But that also means we need to adjust our tooling because over the last 3 or 4 years, thanks to pretty much everybody that works at SpectreOps now, all of us use PowerShell for everything we do. So over the last year, we've really seen the rise of the community kind of moving to .NET, and that's a totally logical step. We leveraged a lot of what we learned in PowerShell, and now we can use this in .NET and hopefully evade all that PowerShell goodness / badness. So we wanted to build this C2 platform, and we were going to build it in .NET because we knew this was really going to be the next big thing. We wanted to build a platform that could help leverage all that tooling that started to come out. And before we even started, though, we really took probably a good 4 or 5 months and just started whiteboarding what does our dream C2 platform look like. And to us, we knew it had to be flexible. There's nothing worse than fighting your tooling to try to achieve whatever your objective is. We wanted it as much as possible to be unopinionated, to let the operator decide how to do stuff versus telling the operator how to do stuff. We also knew that for this to be successful, especially with modern tooling and what's expected out of the community, we really wanted to have a solid API behind it. The idea being that the API should expose everything about the platform. There shouldn't be any secret sauce that you couldn't get to. Everything about it should be open. You should be able to build whatever integrations and tooling and additions that you would like to add. And to that extent, we also knew that we wanted to make things as modular as possible. And the idea behind this was, if you want to extend something, the impact of what you're working on should be relatively confined. You shouldn't have to worry about if I change this here, is it going to break anything, down the chain? So we knew we wanted to kind of, compartmentalize various aspects of the C2. Now, both Bonkers and I, at our respective companies, we're both offensive security people, and we typically work in teams to do our jobs. And so we wanted to build something that was good for our needs. It had to be, a place where our operators could collaborate and work together. We wanted to implement role-based access control so we could, build the platform itself as, secure. It's important. We're handling very sensitive data. We need to make sure that we treat that data as valuable and secure. So we wanted to be able to limit people to, not everybody should be able to interact with all the agents, or maybe you want a read-only user if you have like maybe somebody from your blue team that wants to access the C2 during your operation. And like any other security position, we do a lot of reporting. And the dream that I was kind of thinking of how this would work is that everything about the C2 would be stored in SQL somewhere, so that you could literally just through SQL queries recreate the entire engagement, right? And personally, I do a lot of spinning up of C2 infrastructure. And you spin up Cobalt Strike or whatever, Empire, Covenant, et cetera. And in most engagements, we put some sort of redirect or proxy in front of that, right? So that when you have an implant or an agent connect back, it's not connecting directly to your C2, it's connecting to a proxy that proxy will put in logic of, maybe it's an Apache server that we have some rewrite rules that look at the traffic and decide, oh, is this my beacon? Is this my agent? Okay, we'll send it to the C2. Or maybe it's the blue team or somebody else, we'll send them over here. And it turns out all of that is just a giant pain in the ass, because it generally involves a lot of regex. And regex is very, very hard, and nobody understands it, no matter what they tell you. So we had this idea of, it's such a common configuration, why does the C2 not just understand that this is something that happens? Wouldn't it be cool if we could take these proxies, these redirects, and allow the C2 to maybe talk to them and work together and make it an understood part of the platform? But most importantly, we wanted to build something that was approachable. It's vitally important that we understand how our tools work, because we're making the recommendations of how to fix whatever it is we broke into. And for us to make solid recommendations, we have to understand what we did. You can't go to a customer and say, well, you need to fix git system. Well, how do I do that? I don't know, type git system and do stuff until it doesn't work. You need to understand what's going on. So it was really important that the project have well-written documentation and help messages throughout and just be very accessible and approachable. And that's actually part of where the modular design that we started thinking about comes into play as well. Because when you have everything as kind of containerized, this is in charge of this and this does this, it makes it a lot easier to look at the project and figure out, oh, I want to learn how agent communications works. So that's done over here. I'm going to go read this. I don't have to read through all this source code to figure out where it is. It's a known identified component. And while we were building this, we decided that we wanted to favor simple and effective solutions over complex but more efficient solutions. And that's a balance, but the idea that we were trying to strike is that you shouldn't need to have a doctorate of computer science to understand how your C2 works. It should be something that a relatively intelligent pen tester, red teamer can look at and understand tip to tail how all the pieces go together. So while we started drilling into this modular design, we kept coming back to that. And we kept thinking, what does this look like? And what we decided to do was, instead of having this monolithic Python script or compiled executable, this just big chunk of code, it made sense to split things out into separate services, take the functionality of the C2 and kind of divvy it up. And while we started doing this, we really wanted to make sure, going back to the keeping things unopinionated and keeping things approachable, we started to realize, ultimately this framework doesn't have to care about how it's being used as long as the messages and the data that it's getting matches what it's expecting. And once we started thinking about that, we finally realized, instead of building a .NET C2 with a .NET agent and they're coupled together, why not build a framework where you could write your own agent? Because it's an open API, all the messages are public, it should be relatively easy to write your own tooling if you want to. And that's what led us to build Faction, finally. Faction is a C2 framework in a very true definition of the word. It is built to allow you to easily build tooling and functionality for your personal needs. And that can be internal usage. So if you're a red team and you're building an internal agent, Faction can help provide the entire backend for that agent. You can make your cool, awesome internal agent and not have to worry about, the backend. We got that covered for you. Or if you want to release your own public tool and you have this great idea for, I want to write this awesome agent in Go or whatever, well, we have a server that you can leverage for that. Faction is completely API-based. It features, the API is either available through REST messages, which is a really common API format, or through Socket.io. Socket.io is a real-time communications protocol that's built off of WebSockets. It's really, really cool. There's support in basically any programming language you could want to write your stuff into. When we implemented our role-based access control, we implemented it per API endpoint. So the very first thing when traffic comes in, it's checked to see, does this request, is this allowed? And because it's per endpoint, we can get real granular on building roles and building permissions and stuff like that. And finally, we needed to create some sort of way to interact with this. And most C2s are written as CLI applications. You're typing into Bash or something like that. We briefly kicked around the idea of writing an Electron app. But the very last thing anybody needs on their computer these days is yet another Electron app, because they take up 2 gigs of RAM just to boot up Bloodhound. And sorry, I just had to throw that at you, Andy. I don't even know that your memory usage is that bad. But what we settled on is, why not just build a web app? Everybody has a browser on their computer. Why not make this accessible through just your standard web app? And for our messaging, kind of going back to that point about simple but effective solutions versus complex and efficient, we settled on JSON for our messaging. It's not the most efficient protocol, but it's really easy to parse. It's really easy to look at a JSON message and understand what it's saying, what it's doing. And pretty much any programming language out there has support for JSON. So it's just built in, ready to go. Now, we have this great framework, right, that we're super excited about, but a framework isn't a whole lot of fun without agents to actually connect to it, and so you can hack things. That's kind of the whole point of this. So we built Marauder. Marauder is a separate project. It's a .NET-based faction agent. It is not the faction agent. It's hopefully going to be one of many, as I hope the community kind of embraces this and builds their own stuff. Marauder is really simple, and when we were deciding what does a faction agent look like, we wanted to take a lot of that modularity and customizability of that we were building out in faction and apply that to agents as well. So what we decided to do was kind of build the idea of modules for our faction agents. So Marauder is a great example of this. What Marauder does by itself, when you just run it on a customer or client machine, is it boots up and it really just handles communications and loading modules. That's all it can do. It has no real built-in functionality. But these modules can provide things like commands, or they can provide new transports, new ways to send your traffic over the wire. And that's really cool because now you have this agent, you can load specifically the functionality that you're looking for this specific engagement. Because Marauder is .NET based, it works really well with all that awesome .NET tooling that's coming out. GhostPack, Sharpsploit, all of that cool stuff. You can really easily build new commands and new functionality and just load it into Marauder. So this is the demo part, and I'm going to try to do a live demo. And if there's the slightest hint of trouble, we're going to switch to a video. Live demos are so much cooler, though, so cool. So this is the faction web console that you would log into. The first thing we're going to do, I'm going to zoom this in bit. The first thing we're going to do is click create a payload. Payload in Faction is kind of like your typical stager. This is what you're going to be running on the endpoint to establish an agent, to get a connection to it. So let's go ahead and click New Payload. We have Marauder registered as a type of agent that we can deploy, so we're going to use the Marauder payload type. We're going to get into transports a little bit later, but for now we're just going to use a direct transport. This just literally takes the agent, connects it right back to the Faction API. There's nothing in the middle. Really good for troubleshooting, for building stuff out. Probably not great for like actual operations, depending on what you're trying to emulate. The Faction is able to build payloads in all sorts of formats that you specify. So Marauder features a just regular .NET 3.5 executable and executable with debugging, which has been a pain for like when I'm on an op and I'm trying to figure out why something isn't working. And I have this awesome agent that's built to be super stealthy. Well, it turns out stealth is also really hard to troubleshoot. So we have a debug flag that, you know, this is going to be nice and noisy for us. We're going to see everything that's going on. It's going to be great. We'll set an expiration date for the 30th. So after this date, this agent will no longer work. This payload will no longer work. It will just all stop. Really great for engagements when you have a time limit on, you know, hey, we know this engagement's going to be ending at X date. We can go ahead and set a payload so we have that confidence that we're not still in an environment that we shouldn't be in. So we're going to create this. So right now, the payload's being built in the back end. So one of the things I want to show, though, is this existing payload. If we have this payload, this is a separate file, totally separate file format. You know, this could be, instead of a debug payload, maybe this is our actual like production payload. And what we can do is just disable this. And now this payload no longer works. It will not be able to check in and establish new agents. So we have some sort of control over if this payload's out there. Maybe we didn't set an expiration date. Maybe, you know, we had to call the engagement off early for whatever reason. We can disable this payload. We could also just burn down the entire infrastructure. That would also keep it from connecting back. But this way, if we want to be granular about it, we have that ability. One thing that's not in there yet, but will be added soon, is when the payload checks in, it actually pulls the beacon interval, jitter, and expiration date. This is encoded in the payload when it's built, but when it checks in, it confirms, hey, is this still, you know, what I'm supposed to do? So you can't edit this through the console yet, but the idea being if you had payloads out there, you wanted to change their settings, you could very easily do that. So we got our payload. Let's go ahead and download it. And we're going to copy this over to our Windows 10 box. That's very small, but it doesn't matter. So we're going to kick off this payload here. So right now it's staging. Let's take a look back at Faction. We can see we just got a pop that our agent connected. We could have clicked that notification to go directly to the agent. In this case, I missed it, so we'll just go to the agent menu. So now we have a console for this agent. And this is right now where I really wish I had my demo notes with me, and I don't. So we're just going to wing it. The first thing I would want to do is see what modules are available for Faction. I mentioned that agents are all modular based. So we can issue a show modules command. Let me make this a little bit bigger for you. There we go. So we can see we have two modules available that are registered in Faction that we can use. We have our standard library and we have a Windows library. Let's go ahead and load standard lib. Actually, first, let's set our beacon interval to be interactive. Beacon interval. This will take a minute. We'll also issue the command to load standard lib. And that's going to take a minute. We're at a 5-second check-in. You can see the time of it checking in the right here. This should update as it checks in. I really regret pointing that out now because it hasn't updated. It works, I promise. Or it doesn't. Maybe this demo has already failed. All right, I give up. I'm going to check. You're still working? Uh-oh. No lie, I did this demo like 6 times yesterday, and it totally worked. Like, of course I'm going to get up here and it doesn't work. Show modules. Okay, so let's watch the video of Faction working. Man, I'm so happy I did this. All right, we already saw the logging in part. We saw the payload creation part. That's where I demonstrated that you can enable or disable stuff. We're going to download that. We're going to put that over here. All right. So we'll just talk through this. Sorry, the text is a little small. So we set our interval to 0. So Faction, a lot like other, Marauder, a lot like other agents, has a beacon period where every X seconds it will, check and see, are there new commands that I need to run? When it checks in, it also, if there were commands that it ran, it returns the results of that and posts it to Faction. All right, we're gonna load standard lib. Cool. So now, what we can do is we can show commands. This is showing every command that's available for the Marauder agent. One of the cool things to notice, I'll just use my mouse for it, is it lists what module that command is associated with, and it also lists whether that module is loaded into the agent or not. So you can very quickly see, what functionality do I have available. That's where I demonstrate that with my mouse. So the console is very good about recognizing tabular data, lists of objects. So whenever it sees that, and we'll demonstrate that again in a bit here, it renders it as a table that you can kind of sort. So anytime you kind of see this format, that's a table that you can sort and work with. So we got our list of directories. We've now changed into the Windows directory. We're going to do an ls again. So again, this is a list of file objects. So we can actually sort through and work with this data. This was the sort of stuff I wanted to, the reason I wanted to do a web application instead of a CLI-based application is it turns out the websites are really good at doing stuff. We don't have to use CLIs for, our hacking. Oh no, that's a demo video fail. That's special. Dope. Okay, cool. So we can run our shell commands. This just returns, who we are. Uploading works. What we'll see is when this file uploads, it's really hard to narrate to a video that you've already recorded. It shows up in the Files menu here. This is going to show any files that we have either uploaded to Faction or that we have grabbed from agents. So I'm going to upload a picture of my dog. One thing to kind of notice is we associate the agent name with our file uploads, give you a little context of, hey, where did this file come from? Switch back to the agent. We're going to download that photo of Eli. So we confirm we use present working directory, check what directory we're in. We're going to change to the user's desktop. And then we're going to download that eli.jpg. Should hit that it downloaded here in a minute. Cool. So if we look at the desktop, we can see there's a picture of my pup, who I miss dearly, him and his messed up face. All right. Sorry. one of the things we do is we keep track of all of the tasks that have been run throughout the engagement. So you can go back at any time and pull up the commands as well as the output from that command. And what's cool is since this is web-based, you can just save that, open that in a new tab, share that with other people. It's really good for keeping track of for me, I always end up doing PS, getting a process list over and over and over again because it's scrolled off, I've forgotten what the process is. This way you don't have to do that if you don't want to. You can kind of save this to the side. It's something that's not going to change very often. You can reference it as need be. All of the tables in the main faction window you can filter through. So you have that filter where you can type in whatever you're looking for. It will filter the menu down. That also works for agents, files, anything like that. One of the standout features that I really like about Faction is going back to, we wanted to build something that was useful for us as, security engineers, people that hack into things for a living. And one of the most valuable things we can provide our clients, our customers, are IOCs. So built into Faction, or the Faction agents, when they return the output from a command, they can also optionally list IOCs associated with that command. So in this case, we can see that we ran, who am I? So it shows, hey, here's the timestamp, here's the agent that this was run on, here's the PID that was created, as well as the description of, this was run under this username. For when we downloaded Eli, it actually grabs the hash of that file that we downloaded, keeps track of where did we download it to, stuff like that. I think there's a lot of interesting work that we can do there. So like I mentioned, Faction is designed to be multiplayer. So being multiplayer means we have users. So we're going to create a new user here. It's role-based access control. So right now there are 3 roles in Faction. There's your operator, which is your standard person that's at the keyboard interacting with agents, stuff like that. Admins are basically operators who can create new users. There's not a ton of difference there, and we'll probably, as the community, drives this project, we'll maybe refine that a bit and push more functionality to admin or what have you. And then, like I mentioned earlier when I was talking about role-based access control, we have a read-only user. And read-only users can just look at what Faction is doing. They can't actually submit commands or anything like that. So really good for interns, for blue team members that are kind of playing a white team or like an inside man sort of position. That way they can always keep track of what's going on with your engagement without actually influencing it. So we created our new user. We're going to go ahead and log in as the new user in this right-hand Chrome window. Faction it is built responsively, so technically you could use it on like your iPad or phone or whatever. There's been 0 testing done in that, so good luck. But it kind of works. It looks pretty. And that's the most important part. So we have both our, this is the Jared user, this is the admin user on the left here. We're both looking at the same agent. And much like, Cobalt Strike and other live platforms, we can see as things are happening, everybody's updated. Everybody sees the commands that are run. And really every part of Faction is live, is real time. So when you create a new payload, if somebody is logged into Faction, they're going to get that pop that a new payload has connected or a new agent has connected. It's all real time, and it keeps everybody up to date. And what I need to do right now is vamp a little bit because loading the WinLib takes about 30 seconds. And that's kind of a new thing, and I'm not sure why. But we'll see it load here in a minute. It's a video. I can just fast forward. I forgot about that. We don't have to be awkward. There we go. So WinLib is specifically, Faction is actually, or Marauder, sorry, the Marauder Agent and Faction, was all developed on Linux. A lot of it is .NET based, but we used Mono for most of the development. It's actually been really, really effective. So if you end up on a Linux box and it has the Mono runtime on it, you can use this Marauder Agent. It will totally work. That's why we created kind of that separate WinLib for more Windows-specific commands and functionality. So we're going to get a list of services here. Again, that tabular data that you can kind of sort through. One of the features that was early on, before we realized we had planned a 3-year project and we only had a year to do it, was filtering services, kind of the same way you can do, or filtering that table data, kind of the same way you can do in other aspects of Faction. That'll make it in there again someday. So everything's available. Everything has help. All the commands have help, stuff like that. We'll look at our commands again here. We're going to run the WMI command. So the first thing we do is we're going to get help, WMI. The help, sorry about that audio, people. The help features things like, is this OPSEC safe? Which actually this WMI command is. It's listed as false. That's a bug. $5 for the first person that submits an issue about it. We also include things like, a MITRE attack reference. We include, this was a terrible example, but we include things like artifacts, like, hey, is this command going to leave a file? Is it going to leave a trace? Is there a way for it to be logged? So we try to provide as much information as possible around these commands. So we are going to run a WMI query here, just a simple, give me everything from Win32 operating systems. This actually, the WMI command was a last-minute addition. Carlos Perez gave a great series of webinars about post-exploitation over the last couple months. And his love and passion for WMI, and all the stuff that he does with it from a host recon sort of standpoint, I was like, okay, I need to immediately prioritize getting this done if Carlos is going to take this thing seriously. So again, tabular data, we can sort through, these WMI keys and stuff like that. I think that's the end of the video. Yeah, that's where I click Camtasia and close it. Cool. Seriously, 6 times I went through that demo. Goodness gracious. There you go. I should have stopped at 5, so I had 1 good demo left. I used them all up. Okay, so let's talk about how all this works, right? So when we were deciding to do a modular C2, we really were describing a microservice architecture. So that's kind of what we developed. I say kind of because in researching microservice architectures, it turns out that the people who talk about microservice architectures are very, very opinionated on what makes a proper microservice architecture. If you're one of those people, you're probably not going to be really happy with what we did, and I won't understand why, because it works fine for what we're doing. So we basically have 4 services, right? We have our console service, and that's what is exposed to the internet. It's really just an install of Nginx that hosts that console, that web app, and also provides the entry point for the API. The API is a separate service that handles really just all the API messages that you would expect. And it's also in charge of all the authentication. So that's where users and passwords and stuff like that is handled. The workhorse of Faction is the core service. Core handles really all the agent and user messages. They eventually get to core. Core is the only service that should decrypt agent messages. Everything else, should be a kind of a zero knowledge, I just have this encrypted message, I'm sending it down. And we wanted to go with that route because, again, going back to the data we handle as pen testers, as red teamers, is incredibly valuable. We want to make sure that we keep that as secure as valuable until we absolutely need to decrypt it. And lastly, we have the concept of build servers. So a build server is a development environment that handles building those payloads, those agents, modules, stuff like that. Right now we have a .NET build server that provides Mono and MS Build and stuff, and that way you can build those modules, you can build Marauder. But hopefully we'll have more build servers in the future, Python payloads, Go, stuff like that. It'll be really driven by what the community is interested in doing. And if the community is totally not interested in Faction, it will be whatever I feel like doing. All of these services talk to each other through RabbitMQ. It's a message queue, And they use just simple JSON messages that they pass back and forth to tell each other what to do. And finally, for our database, we just have a Postgres instance that stores pretty much everything about the engagement. A diagram looks something like this. So you have a console connects to API, and then they all talk through Rabbit. But let's drill into that a little bit. So during the demo video, I issued a command for load standard lib, right? So what happened there was console posted a message to API saying, hey, I'm interested in this agent, agent 1, and here's the content of the command. So real simple, if you want to write your own interface for a faction, real simple API to interact with. API takes that and it says, okay, this is a new console message. So I'm going to post a new console message to RabbitMQ, and I'm going to tell it what the agent ID is, what the user ID is, because API knows that, and what the content of the message is. Core then sees, okay, there's a new console message. This is something I need to process. And it looks at it and says, okay, this is a load command, so I need to tell a build server to go load something. And I know because I looked up what the agent was. I know this is a Marauder Agent. I wasn't told to build anything else, so I'm going to assume that they want a .NET module called standard lib. The build server sees this module or this command come in, says, hey, I'm a .NET build server. This is my time to shine. And it looks up in Postgres and says, okay, I'm looking for a module named standard lib that's for .NET. And Postgres returns the record of this entry, the registered module that's registered to this name. The entry includes 2 fields that are relevant at this step. One is the build command. So one of the things that I think is really cool about the flexibility of Faction is we don't enforce, this is how you compile code. The build servers are really just a development environment, and you give it a command and it runs it. It's going to run MS build against this file. And so that's where you can start doing things like, obfuscation or have your debug flags, and you really are just running a command at the end of the day. You don't have to worry about is this the Faction way of doing things? Just write a bash script and run it. The other relevant part is the build location, which just tells the build server, hey, when I'm done building this, this is where this artifact, in this case, the DLL, is going to be. So the build server grabs that DLL, it's the standard lib module, and grabs the contents and base64 encodes it, and then returns that to, I'm in the way of the important parts. Returns that to core, because core had asked, hey, I need a standard lib build. Core does 2 things back to back. It creates a task for the agent that says, hey, here's a module for you to load. And then it takes that task and it encrypts it using the agent's password. It associates an IV and an HMAC with it. Faction on the server side checks HMACs for every single message. If you're building an agent, you should as well. That's how you know that your message hasn't been tampered with. And so it takes this agent task message and it saves it to the database and it flags it as this hasn't been sent yet. Pretty straightforward, long explanation, but I think each step was relatively straightforward and easy to understand. So when your agent, your malware, your implant, whatever you want to call it, checks in, what happens is it comes in, it goes to the API and says, hey, I'm agent name this, and I'm checking in, do you have anything for me? API, all it does is looks into SQL and says, hey, are there any unsent messages for this agent? If there are, it base64 encodes that list of messages as, it's a JSON object, and it base64 encodes it and sends it back to the agent. Now, if you're into red teaming, if you're been doing this for a while, hopefully that last step raised your hair a bit because our agent's connecting directly to our API, and that's not good OPSEC. You really don't typically want to do that. So I mentioned, we wanted to find a way to integrate the concept of proxies or redirectors into this framework. And what we settled on is transports. So transports sit in front of the API. They're a separate server, and they have a corresponding module that sits inside the agent. So together, this module and this transport server, they work together to take that base64 message from API and chop it up and do something with it. It really doesn't matter what they do, because really as long as the message goes in one end and comes out the same on the other, then nobody cares. API gets the message it expects, your agents get the message they expect. You know, you could, I'll get into better demos. That's a real insult to my talk. Anyways, so let's do this example first. So we're releasing a HTTP transport. It allows you to create a website that hosts, or acts as that in-between for faction messages. It provides malleable profiles. You can kind of customize it to do whatever you want. In our case, maybe we customized it to look like a bank, a chat service at a bank, right? So our agent, when our agent says, hey, I have a message to send, it sends it to the transport module that is inside it. And the transport module says, okay, I'm going to make this look like a chat message. So it posts a request to totallyAbank.com and says, okay, I'm a customer. I'd like to talk to you. Here's some encrypted bank data. And that's really the payload. That's not actually encrypted bank data. We're tricking people. So the transport server knows, hey, that's not really bank data. That's like a payload. And it's going to send it as a check-in, because it knows, if you look, we have when we post it in, we have that header saying, hey, this is my agent name. So the transport server is able to say, okay, I got this agent name, I have this payload, I'm going to send this as a check-in to the API. The API doesn't care that it's a transport that's talking to it instead of an agent. That's the beauty of an API. It doesn't care how it's being used as long as the messages work. So it replies with the list of tasks for this agent, right? The base64 encoded string that we've been talking about. So maybe our transport server now responds to the agent with a web page. And hidden inside this web page is the base64 response from API. Again, this is a really simple example. You'd probably want to get a little bit more complex. But our agent is smart enough to say, oh, I don't need any of this other stuff. Here's the message for me. It extracts it, and it processes it. It's probably one of the most different aspects of Faction. But I think it's also one of the potentially coolest aspects of Faction. There's a lot of, I think, really interesting stuff that we can do with transports. Because really, like I said, all that matters is you get that string from A to B. So you could take half of that string and put it in a PDF and post that to like Google Docs or something like that. You could take the other half and put it in like a picture of a puppy and post that to like Imager or Instagram or whatever, as long as they don't strip out that payload. As long as your module that you've built knows, okay, I need to check Google Docs for the first half and Imager for the second half, it's fine. That's all you have to worry about is getting from point A to point B. And it's important to note that it's not just HTTP that you can use. Any way you can get that string to your agent is a completely valid way to, build a transport. Oh my God, I said I was only 15 minutes into this talk and I was going to freak out. I'm not used to your fancy military time, your 24-hour time. Okay, so let's talk about how you develop all this stuff, though. So transport servers, since they're just interacting directly with the Faction API, you can write them however you want. It's an API client. You can write it in whatever language you're comfortable with. As long as it can talk to the API, that's all that matters. For modules, what we decided to do, the modules, like I said, they're what extend Faction agents. They provide those commands, those transports, stuff like that. And what we decided to do was make a standard for what these kind of looked like. The reason being, we don't want modules to be agent-specific. If you have a Faction agent, you write it in, Go or whatever, and your Go agent can leverage the .NET runtime, It would be really cool if you could leverage all the .NET modules in Faction, because you understand how they work. So we came up with the idea of faction language standards, which kind of define what do these objects look like for a given programming language. Right now we only have .NET because that's all we've been working with, and we've already spent a year on this project, or over a year on this project, and I'm done developing for it for a bit. So let's look at what transport looks like. So if you wanted to build a .NET transport, or a transport for Marauder or another .NET agent, we provide a common library for .NET through GitHub. And what you're going to do is inherit this agent transport object, and then you're going to overwrite the beacon and the staging method. Pretty simple. They take a little bit of identification, and they take a string, that base 64 encoded string that you need to pass to the API. Your agent doesn't care what happens when it calls beacon or stage. It just knows, hey, I'm going to give you this, and you give me back a base 64 encoded string. How that happens doesn't matter. That's part of the joy of it being modular. I think that covers all of that. Commands are actually even easier. If you want to write a command for a faction, or as a faction.NET module, you inherit the command object, and you overwrite the execute method. The execute method takes a dictionary of strings, and that's the parameters that you would be passing to your command. When you register your module with Faction, you tell it all of the commands that are available in it, as well as all the parameters and what values they're expecting, is the parameter required, stuff like that. And what's cool about this is Faction is smart enough to do some logic checking before it sends the command off to the agent. So if you have a command that has a required parameter and your operator doesn't provide it, Faction will drop that, throw a message back to the operator saying, hey, you didn't provide a path, and this is a copy command. I need to know what you want me to copy. These commands return a command output object. And this is a really straightforward object, but we needed some way to kind of standardize on what information we need from commands. So it'll include things like, was the command successful? Did it complete? What was the output from the command, as well as that list of IOCs that I was talking about during the demo. The IOCs are probably the most opinionated part of Faction, and that's because we really wanted to standardize. We're using this for reporting. It can't be a bunch of free-form fields. Like, there has to be some sort of structure to this. So I asked a lot of instant response, blue team friends of mine, kind of worked through this, and what we came up with is, you need to tell us what type of IOC is it. Is it a file, a process, registry, or a URL? Then you need to tell us what you did to that object. Did you create it, delete it? Were there these HTTP methods that you used? Some sort of identifier. This is free form, but something that will be useful to the blue team, a PID, a path, URL, whatever. As well as there's an optional hash that right now I can only think of it being applied to files, but it's there in case you want to hash other things that you're returning IOCs for. And lastly, a little description that we can display in reporting or display on the console of what happened. Oh, this user started this process, this file was deleted, what have you. The other thing you can do to develop for Faction is to build your own agent, which is, a lot more complicated than building modules, but hopefully not unapproachable or not too confusing. Really, an agent needs to do 5 things. It needs to get a message from the API and decrypt it. Whoops, there we go. Get a message from the API and decrypt it. That's going to give you a task, so you need to take this task and do whatever it says to do. The task action is also limited. It's not free form. You don't have to worry about figuring stuff out. It's going to be run a command, load a module, set a setting, or use a transport. 4 things that you have to worry about processing. Then you build your results from whatever that task was. Here, optional IOCs that you can include. Finally, you encrypt those results. We use AES 256 HMAC throughout all of Faction. Again, most likely, if it's not native to whatever you're programming in, there's probably a dozen different libraries you can leverage to use AES encryption. Then you take those results, base64 encode them, and fire them off to the API. So let's talk about what's next and, well, where we're at right now. So today, actually as of an hour or so ago, Faction was released. It's up on GitHub. It is in an alpha state. Basically, there are some API and schema changes that kind of came up late when we had decided not to make any changes to the project. I'm going to try to get those in here pretty soon. But one of those things will be adding .NET 4.5 support to Marauder. Right now it's just 3.5. But we kind of figured out one of the challenges of developing Faction is actually that decoupling Marauder, because we can't just say like, oh, well, this will work for Marauder. We need to try to come up with solutions that are broad and useful for more than just our agent that we're working on. We figured out how to do that, and we'll be making those changes soon. Once Faction enters beta, our thoughts on beta is that the API, the schema, should be relatively stable, especially the APIs that you'll be relying on for building agents and transports and stuff like that. That should be rock solid by the time the beta drops. That way you don't have to worry about us making changes, throwing off your development, stuff like that. When we're in beta, Bonkers and I are gonna focus on bug fixes, documentation, polish. We've been saying something about test for the last, like, I don't know, year. And I always have like really good intentions when I write programs. I'm like, this is gonna be the one that I write test for. We will probably maybe write test for Faction. It's something we really need to do if this is gonna be a serious project. We'll do it eventually. Or if you want to be really awesome, you can do it for us and submit it as a pull request. That would be great. But finally, we're hoping to have a stable, awesome project available by the end of the year. Probably last 3 months of the year or so is kind of what I'm thinking. So if this is something that interests you, this would be great if you download it and use it. Let us know. You know, it's super important. One of the core principles of building Faction is it should be understandable. So if you're using it and something doesn't make sense, or, you know, the documentation doesn't make sense, we want to know about that. You know, submit issues. Let us know what's broken. It's really important to us. We want Faction to be, you know, the community's framework. We want this to be something that everybody can feel, you know, like works for them. And that's an incredibly ambitious goal, but I'm hoping with the help of, you know, all of you, we can make it happen. God, there was another really important point there, and that's not gonna make it into the talk because I don't remember what it was. So if you are developmentally inclined, building modules, building transports, building new agents, that would be absolutely awesome. Would love to see what people are interested in and how to, you know, leverage this. So that's the end of my talk, which was surprisingly good time on my part. Pat on the back. If you want to learn more about Faction, you can go to, actually it's just factionc2.com. That finally worked, like at 2 o'clock 2 a.m. Yesterday. That finally took effect. But everything is up on GitHub. This is a completely open source project. I have a love and passion for open source, and I really hope we've made something cool that everybody else enjoys. That's what I was gonna say. I would be so stoked if this is somebody's first like project that they developed something for and submit a PR for. Like, I really hope it's that approachable that like people who, you know, think, oh, I'm absolutely not a programmer, feel comfortable building stuff for it. That's really what we're aiming for, that level of approachability. So yeah, that is it. I am Jared Haight on Twitter. Bonkers doesn't have an account because he's a bunny that lives in a hat and he doesn't get internet access. And that's it. Oh, sorry, I think you take that from here. Any questions?
No, please, please.
Any questions?
Oh, yeah, jackpot.
Hi there.
Yeah, hi.
Have you thought, or maybe you've already implemented grouping agents and multicasting?
We have not, but we started to develop it, and then again, as that like, oh no, we've created a 5-year or 3-year project, like I need to start trimming. I know exactly how I would implement it, I just haven't implemented it yet, but totally on the roadmap.
No, thank you.
Basically, so the agent list, for a while there we had checkboxes where you could just check and select agents, and so the idea would be you check and select what agents you want, and then that would give you a menu where you could do bulk actions, run commands, delete agents, whatever. So it was that close to making it. Thank you, good question.
Yeah. I understand that this is a tool for red team testing, right?
Correct.
What I'm wondering is, how do you get the Marauder shell on the target system in the first place?
So we are, at right now, that step isn't a big focus of the framework, because I know personally when I'm on an engagement, I always come up with something custom for the engagement, right? So since it's a .NET binary, really, I mean, you could encode it into a PowerShell command, put that into a phishing message. It would work with, there's a project called .NET to JS, which basically takes a .NET assembly and makes it into a JS file. So really, pretty much any way you could execute PowerShell or code execution or something, there's a ton of ways you could load this, into memory or drop it to disk and run it.
Thank you for a great talk.
Thank you.
Have you thought about encryption from the malware to the client side? Because it's all encrypted in the servers now, right?
Well, all the traffic, the agent itself does encrypt all of its messages before they're sent out.
Yeah.
Is that what you were?
Yeah, I'm thinking about, so the server decrypts before it returns to the browser, the data.
Oh, so like
know,
decrypt in the browser?
Yeah.
I have thought about doing that. That would be difficult and complicated to implement. So the way I would implement faction is restricting the console to basically where are your operators coming from and what are your transports. Those are the only things that need to be able to talk to the API. It doesn't address, it's not that encryption all the way out the door, but it at least does provide protection to kind of keep the API, safe. But that's about where I'm at on it.
Thanks.
Yeah, absolutely.
Hi.
Hi.
Thank you so much for this good and promised tool. I have several questions. First of all, did you test in real engagement? So let's say you spawn 100 agents somewhere. What's happening? It's still stable or?
So no, because faction is in alpha right now. Like,
okay.
As demonstrated by the demo fail, like it's not quite ready for operations yet, in my opinion. You're welcome to use it on your operations. That's right. If you want to deal with that like mess of trouble, help yourself. But I haven't used it on operations yet. It is internally, it is becoming. We're working towards making that the standard for our tooling, though. So we'll have a custom, internal in-house agent that we'll use when necessary on our engagements. But it will be leveraging the faction backend. But it's just not there yet, in my opinion.
Good. Next question.
Yeah.
Do you plan to have a wiki or something like that for developing, to exchanging, make some documentation? So for example, if you try to develop your own agent, to sharing what are you doing, and so for people, so for example, let's say I work essentially on, so I target essentially macOS laptops, so I need to develop everything for Mac and use the faction. Maybe I can share what I did and make some documentation around that. So do you plan to support some wiki or just on the GitHub?
A wiki is a really, really good idea, and I haven't considered
something where we can share some documentation.
Yeah.
So that's why I'm...
So the The documentation itself is all on GitHub, so it's all like, it's really easy to edit, but we don't really have like a wiki platform. But I would have to think with that, but that's a really good idea, and it should be relatively easy to implement. Yeah.
Thank you.
Thank you.
More questions?
Oh, I have a lot of faction stickers. If you want faction stickers with that awesome logo, hit me up. I have a lot of stickers. You are welcome to a lot of stickers.
No more questions? All right. Thank you, Jared. Great talk.
Thank you very much.